At this point, I have finished facing off all the gears, and I've come up to the next step, which is to sand them and make them, give them their final finish. Now, there's a lot of disagreement. I don't know if that's the right word, but the decision that each of us has to make in the process of making something like this is, when do you do the finishing operation? And typically it is done, at the end of the process when you've finished with all the machining. The problem with making gears is that once we begin, cutting teeth into them, and on many of the gears there are going to be spokes and such cut into them, it becomes very difficult to sand them because the sandpaper doesn't have a flat surface to work on. It will continue to go into the valleys of the places where you've cut. This is the easiest place to do your sanding, and I prefer to do sanding, especially round parts, on the lathe, because the lathe is doing all the work and I'll just be moving sandpaper over it. The downside, of course, is that I have additional machining operations to do, and any one of those can, scratch the work that I've just finished beautifully sanding. So you have to decide based on the project when you're going to do this particular operation. I've decided to do it now. Maybe later in the process I'll decide that wasn't the right time, but this is the way I've chosen to do this. So I'm using the same setup I did before, using this spindle that I made that held the gears in place when I was facing them. It's held at the back with a live center so that the spindle rotates freely, so it's not burning a hole here. I'm using a product called Micro Mesh, if you can see that. It's a wonderful sanding product that's intended for doing metals, plastics, and even woodworking. But the beauty of it is it comes in a whole lot of different grades, and you can get a very, very nice finish using this. It has a flexible fabric backing to it, and it comes in various size sheets. In this particular case, I've cut those sheets down to a manageable size for what I'm doing. The micro mesh comes in various grades as well. This particular grade I'm using is their MX grade, and you can find this on the internet. It's pretty easy, but the MX grade is intended for metals, except for aluminum, where they have an AX grade. So I'm going to begin, and this is again through experience. I'm starting with what they call 80 grit. Now their grits do not map directly to the grits of regular sandpaper that you find in a home center, but they do have a chart that shows you what their grits are versus other types of sanding products. But again, I'm going to use 80 grit to start, because you want to remove any of the machining marks that were left behind from the facing operation. And then I'm going to proceed through the grits, and I'm going to go up to what they call 360 grit. Now they have grits below this, below the 80 and above the 360, but I found that for this particular gear and this alloy of brass, which is alloy 353, that this seems to work the best. Now, you can work wet or dry. I think it works much better if you work wet. So off camera here I have a little Tupperware container with room temperature water in it. I've just wet the sheet. I'm going to start up the lathe. It's running at around 1,000 RPM, in that neighborhood. And the objective is just to go very gently, because this particular type of sandpaper, especially because of the backing, it's made so that the grit on the sandpaper actually rotates back into the backing and out again, so it's always exposing a sharp edge. And if you apply pressure, you defeat the whole design of this particular type of sandpaper. So I'm going very, very gently. I'm always keeping the sheet moving. I'm keeping it wet. And I'll stop the lathe from time to time and take a look and see how I've done. But once the machining marks have come out, you move to the next grade. You always go sequentially through the grades as they're provided, whether you're using this sandpaper or any sandpaper. Because sandpaper is designed so that each grade removes the scratches, each finer grade removes the scratches that were left behind by the previous grade. Of course, it replaces them with new, finer scratches. And what really is happening, and you see as I'm doing this, I'm getting brass on the sandpaper, but that, as I dip it in the water and just rub my finger on it, that comes right off, cleans it up again, and it's ready to use again. I'm going to just very gently with a paper towel get the water off here. I'll stop this for a second. But as I inspect it, I can see that there's a nice consistent scratch pattern in here, left behind by the sandpaper, which is exactly what you want. As you move to the finer grits, like I said, these scratches will be replaced with finer and finer ones, and ultimately when you get to a scratch pattern that is fine enough, light will reflect off the gear rather than being refracted through the scratches. And when the light bounces straight back at you, that is when something appears shiny or reflective. So anyway, I'm going to now move to the next grit, which happens to be 100. And I'm just going to continue this process. It's mindless, but it certainly takes a long time when you consider how many gears I've got to do, and they both need to be done on both sides. But if I'm right, this will end up being the best place in the order of processing to have done this. What I've thought about what I might do to protect this later when I have to go back and cut teeth and so forth is to cover the gear with a piece of contact paper to protect the finish. This is pretty common. I've purchased, like for example, this piece of aluminum has a plastic, sort of like contact paper backing. This particular piece of aluminum was bought with a mirror finish on it, so it comes from the factory, with this protective coating. And if you're careful with the coating, you can do the rest of your machining operations on here, and then remove the coating as the last step. So that's essentially the model that I'm following. And I'm just going to, I'm now moving to the next grit, and I'm wetting the paper again, cleaning off any grit that was left behind from the last gear that I did. This particular gear is, I don't know, about 2 1/4 inches in diameter, and these haven't been cut to the final diameter yet. They still have the rough edges that were left behind by the bandsaw, but that too I think works in my favor, because for some reason The hardest part to sand are the outside edges. I mean, that last little bit. And since those are going to be cut off when I turn these down to their final sizes, that'll just remove the part that didn't get completely sanded. And you can see already that, I hope you can see that, I'm just tightening this up a bit, but we're getting a beautiful finish on here, and I honestly just don't think that would be possible doing this at any other stage in the operation, because you certainly can't put it back on the lathe after you've cut teeth and spokes into it, otherwise you get that interrupted cut. The sandpaper is always bouncing off it and it never gets a flat finish. So what you're left with is doing the opposite of this, which is taking the sandpaper and putting it on a very flat surface, and then taking the part, and it's called lapping, but you're moving the part in a figure-8 pattern to remove any scratches. And although that works nicely, and some people are very adept at doing that, I've never been able to do it as well as this particular operation on the lathe. Some of you are probably also horrified at the fact that I'm using water near the lathe, or that I'm even sanding near the lathe. It is my belief that tools are meant to be used to make things, and I've got tools in this workshop that are older than most of you, and they've been put through some pretty harsh environments. But if after doing this process you immediately clean up, and that might mean breaking the lathe down and getting in and cleaning everything out, but I'm willing to do that so that I let the tool do the work, because that's why I buy tools. All right, at this point I have proceeded through all the grits except for the last one, which is 360. It's not the last in the series, it's as far as I'm going. I think it gives me just the right finish that I'm looking for this particular project. But you can probably see, I hope you can see, that the gear is a whole lot shinier, smoother, than it was when we started out. In fact, it's got a very nice finish to it. There are other operations. There's a buffing operation that I'll do by hand after the gear is completed. I use a product called Simichrome. It's a paste specifically made from metals, and it removes the very fine scratches. And it leaves behind a protective finish, because brass and other metals have a tendency to oxidize. This protective finish should really slow that process down. So, but I won't be doing that until a lot later, and that'll be done by hand, as I said. And this is a damp paper towel. Certainly wouldn't use a dry one on this. And now I'm going to take a piece of cotton cloth, and just make sure all of the grit and water are off the gear. So at this point, that's the finish I'm looking for. It's ready. It took probably about 15 minutes altogether to do one side of one gear and to listen to me talk about it. So, but this is it's a long process. This happens to be a medium-sized gear in this particular process. I've got some that are considerably larger than that, and you may have noticed I've got a higher riser block on my lathe right now. This is a 2 1/4 inch. It just gives me more room to work, and my tailstock is one that can get me up to that height, because normally it would be quite a bit lower.